Okay, so as we discussed yesterday, what are integrals? Integrals are just the inverse of the differentiation.
Yes, sir.
So in
Yes.
differentiation, let's for take a simple example. If we had x and if we were differentiating this, then we were getting 1, right? So
Yes.
if we want to integrate 1, if we are now integrating 1, so what we'll be getting? We'll be getting x.
X.
This is the whole idea about integration. That integration is the is the inverse, or you can say the opposite of differentiation, right? And in differentiation,
Yes.
we were, let's suppose we have a function. So what we were doing is we were, taking very small part. This is dx part, right? And then in integral, what we are doing, we are taking this dx part and we are moving this along this function, and whatever the limits are, we are saying what area this dx strip is taking here, right? So we are doing fx dx. So whatever this strip is forming now, this has the width of dx, and this has the y value is the function's value fx. So if what is this? This is going to be the area of this strip, this small strip. Now we want to
Yes.
move this strip along this entire limit that we have, and then we integrate that. So that will give us the area from this point to this point under this curve. Okay,
Yes.
so let's see some of the basic rules. As we learned the basic rules of differentiation, let's see how we have the basic rules of integrals. So the first one is, as we have seen, that if you have, okay, one more thing that we want to talk about is whenever we integrate, we write something like plus c, right? So whatever the integral is, after getting that value, we write plus c.
Yes, sir. There's a
So
constant.
yeah, why do we write that? Why do we need? We don't do this in differentiation, right?
Yes, sir. Because constant gets derivated as a zero, so you never
Yes.
know if there's a constant at the end or not.
Yes. So let's suppose, for example, if we are integrating this one and we are getting x, so we can say, okay, because the differentiation of x was one, therefore the integration of one is x. But what if we had x plus three something, right? So
Yes.
then again, the
So we added
differentiation will
C.
be one, but the we can see the integration is something else. So we can have anything, but uh, because we know that we are getting one, so that means whatever this value is going to be, that is going to be an constant value. That's
Yes,
why
sir.
this differentiation can be zero. It may be possible that there is no constant, but if there is some value, that is going to be a constant. So that's why whenever we integrate, so we write plus c also.
Yes.
Okay, so in differentiation, the first formula that we learned about was how do you differentiate something like x raised to the power n, right? So how do you differentiate this? So we learned that this is going to be nx n minus 1. In here, whenever we do integration of such type of function, so if you have x raised to the power n dx, how is this going to be? You are going to, here you were decreasing a power, so you can assume that because the integration is just the opposite, so you are going to do addition 1, right? You need to add 1, and then here you were multiplying by this n. So what you will do, whatever this n plus 1 is, you will also divide by that, right? And then obviously plus c should be there since this is an integral. So this is going to be integration of something as x raised to the power n. All right. So for example, if you have x square and you want to differentiate this, what you need to do is you need to add 1 to the power, and then whatever the power is, you need to divide by that. So x cubed by 3 will be getting whenever we differentiate x square. Okay. Then let's see if you have the if you have 1 dx, right? This is dx, but what we are saying is if we have a constant like let's say 1 dx, so what this is going to be, this is, we have seen that because the differentiation of x is 1, that's why the integration of 1 dx will be x, and then there should be a constant also. Then let's see if you have 1 over x dx. So 1 over x we know, because the differentiation of log x, whenever we do differentiation of log x, we get 1 upon x, right? So that means if we do integral
Yes.
of 1 by x, we will
Then
get log
it will be
x.
long.
Next we have e raised to the power x dx. Now e raised to the power x is very simple function because we know that the differentiation of e raised to the power x is also e raised to the power x. So if I shift this differentiation to the right hand side, yeah, so this will be same, right? And then the last function, last basic function that we need is something as a raised to the power x dx. Now, what was the differentiation of a raised to the power x?
So yes,
If you want to do this, it included something like log, right? Do you
yes,
remember this
sir.
differentiation of?
Sir, I remember the integration of a to the power x, which is
Okay, what is the integration of a raised to the
which
power
is
x?
a to the power x divided by log of a.
Okay, and the differentiation was a raised to the power x log a, right? So
Log a.
similar
Oh,
thing,
okay, okay.
if I have to shift this to the right hand side, this will become integration, and then this log a is constant, so you can take this log a on the this side, so this will divide. So that's why
Oh,
the
yes,
integration of
sir.
a raised to the power x will be ax over log a. All right. So these are the basic five formulas that we need right now to be able to uh, get through the first exercise. All right.
Yes,
Okay. So let's take the first exercise. We have first. This is chapter 7, right?
yes, it's that chapter 7.
Okay. So first one we have x raised to the power 5 dx. Now very simple, we are going to use the power rule that was if you have to different integrate x raised to the power n dx, you're going to raise one power and then you're going to divide by that. Right? So what we
Yes,
just need to do, we need to add one
so
to the
this is
power and we need to
and
divide.
so the x to the power 6 divided by 6 plus 6.
Right? And then if next is 1 over x raised to the power 3 dx, so similar to what you were doing in differentiation, whenever you have something like this you need to write this in the numerator, right? So that
Numerator
you can be able to apply this formula. So we can write x raised to the power minus 3 dx,
minus
and
3
then we can add 1 to the power, so we'll get negative 3 plus 1 and
minus
we get negative 3 plus 1 plus c. This will become x raised to the power minus 2 over minus 2 plus c.
plus
So
6.
then it will become minus 1 by 2. This x raised to the power minus 2 can be written as this and then plus c.
Yes,
So the third one is 1 over square root of y dy. So
so it's
same
the
thing
same
will
thing.
be,
I just bring it up and we do
yeah.
minus 1 by 2. Yeah,
So then we'll be adding 1. So minus 1 by 2 plus 1 will become
will
plus 1
become
by
1
2.
by.
And then you
So
need to
the root
divide
y.
by the same.
Root y
So
by 2.
this 2
2 root
will
y.
like right, 2 root y plus c. So
Yes,
also you can remember this rule because we will be getting this very often in our questions. So it's good to remember the integration of 1 over root x dx, which will be 2 root x.
2 root x.
Right?
Yes.
And what was the differentiation of 1 over root x or root x? The differentiation of root x,
Also,
1 over 2 root
so
x
again,
because,
I have 1 by 2 root x. Yeah.
yeah. Okay. So let's do second one now. We have 5 raised to the power x, right? So here we have to use the ax rule, ax dx if you have. So what we'll be doing, we'll be doing ax over log a plus c. So this can be integrated to 5 raised to the power x over log 5
Log
c.
plus 6.
Okay, next we have 7 raised to the power x and e raised to the power x. Now it's looking like we are multiplying two functions, so but we don't know how to integrate. As of right now, we don't know how to integrate two multiplying functions. Right? We have this rule in the differentiation product rule, but here also we have a product rule formula, but right now we haven't learned that. So how can we do this? Is because we know 7. and e both are constants, right? 7 is also a constant
Yes,
and
sir.
value of e is also 2.31 something. So this is also a constant. So and the powers are same. So we can write this as 7e raised to the power x. All right. Now we have now
Yes,
this is a and we have a raised to the power x. So we'll do 7e raised to the power x over log a.
log
A here is 7e.
7. Yes,
Right, I think further we can break log 7e into log 7 uh, plus log e, but I think it's fine here. Then we have same thing 4 raised to the power x over 9 raised to the power x. So this can be
yes,
written
sir.
as
So it will be 4 by 9, the whole x.
yes. So we'll get 4 by 9 raised to the power x over log of 4 raised to the power n.
Yes,
Okay, and then plus c. Okay, then the next one is e raised to the power 2 log x times x raised to the power minus 3 and dx. Okay, so we
sir,
know
I
one
want you,
property. Yeah,
I want to take the 2 to the x and then e log will become 1, right?
yes, yes. So we have this property where if you have e log x, then you write this as only x, and but the condition is log should be empty, the coefficient should be 1. But if it's not the 1, then what we can do, we can shift this 2 here in the power of x. So we can write this as e log x square into x minus 3, and then e and log will basically remove themselves in x square times x minus 3. Now you are multiplying and the base is same, so powers will add, you'll get x minus 1. And do not use power function here, like power rule for integration, because if you use the power rule for integration right here, what you'll get is not defined, right? Because in
Yes,
we
sir,
know
will
in
be
the
0.
denominator we do n plus 1. So minus
Yes.
1 plus 1 will give 0. So that's
So
why
then
this is
we'll
log
use the
x.
1 by x uh, to get
Yeah,
log x.
this is
Yeah.
this is 1 by x dx. Okay, and next one is 5 raised to the power 2 log. Okay, so this formula, this works even without. Okay, so what is happening here is this log is also natural log, right? So whenever these two power, the base and whatever number you have taken to power 2, that is same, then you get this x. So it works with any other also. So if in general if you have a and then you are doing log base a x, right? So if these two things are same, then also you get x.
Yes, sir.
All right. So in the second
Okay.
part also we can do the same thing, that first of all we can write this as log base 5 and then x square, right, dx.
Yes, sir. And then the 5 log 5 is 8 also.
Yeah, and then this will be x square dx, and then this will be x cubed by 3.
Yes.
Okay, next one is kind of tricky. We have the third one as 2 raised to the power log 4x dx. So here we cannot see, we can see that the numbers and these two values are not same, right? But
Yes,
can
sir.
we make them same? Can we do anything to make this 2 either 4 or make this 4 as 2?
So I think you can do something.
Yeah. So
I'm not
we
sure.
can write we can write 2 as square root of 4, right?
Yes, sir. You can.
So if we write this 2 as 4 raised to the power 1 by 2, and raised to the power log raise 4x plus c and plus c dx. So then we know that whenever you have a raised to the power m raised to the power m, these two powers are just multiplying. So this will be 4 raised to the power 1 by
Mm.
2 log 4x dx,
And then
and then we
the
can
one
shift
by two
this
will go
1
to
by
that.
2. Yeah, so we'll
Okay,
get
okay.
x raised to the power 1 by 2.
Yes, got
Right? So this is then square root. So 1 by 2, we can add 1 to get 3 by 2, and then in denominator also we'll get this 3 by 2. Then this 3 by 2 is same as 2 by 3 times x 3 by 2, because this 2 will come up and this 3 will remain in division.
yes, done.
Okay, so this one has only 3 questions, right?
Yes, sir. Understood.
These was like just based on the common functions, that these types of functions. So you have logarithm function, you have, if you have polynomial function you can do like this. If you have 1 over x type, if you have exponential, or if you have uh, this one is also exponential but raised to some different than e. So then let's start the next exercise also. This one was very short. 7.2. So in 7.2, what we will be doing is we will be first of all looking at some of the properties and then using that properties to simplify. Okay, so let me write up some of them are very basic and some of them also relate to differentiation. So whatever we were doing in differentiation. So the first one is, if you are ever differentiating and then also you are in, like you're differentiating the integral function. This is what you're doing. You are differentiating the integral function. So what you will be getting is, because these are to the inverses of each other, so you will get fx as it is. You do not need to change anything, right? So you can say like differentiation and integration cancel each other because they are like inverse of each other. So second, if you have something as we have in differentiation, if you have any constant multiplied to your function, so same thing in differentiation, we take this out. Same thing we'll do here. We'll take this out and we'll just focus on the function. All right. And then the third one is, if you are having something as f uh, f1x and then plus f2x and then plus f3x and so on. If you have like n functions which you are adding, so if you have like a polynomial functions, right? You have x square plus x cube plus x4 plus x5 and so on. If you have something like this, and then you are differentiating integrating that, so what you can do is, right now this is inside the entire integral, so you can just break this integral over entire functions. So you can write integral of f1x dx plus integral of f2x dx, then integral of so on, and then fnx dx, right? So you can just basically split this over entire uh, functions, right? Similar to what you were doing in differentiation also. If you have something as x plus x square, right? So you will be differentiating x, then you will be differentiating x square, right?
Yes, sir. There will be one.
Yeah, 1 plus 2x. So same thing here. If you have integral of x plus x square, so first of all you will be integrating this x, then you will be adding, and then you will be integrating x square, right? So fourth one, we can combine these two and write one more property, but that's okay. We do not we can do this. So let's jump to the exercise now. Question number 1, size 7.2. So first one is ax square, a quadratic function bx plus c times dx. So using the first this property that we just learned, we can split this integral, because in multiplication you cannot do this. So if you have x times x square and then you are differentiating this, so you cannot say differentiation of this multiplied by differentiation of this, right? You have to use product rule, or you have to multiply then differentiate, right? So same thing here also. If you ever have multiplication in between, then you cannot split. But if you have addition, then you can split this integral over all of the terms which are inside this addition. So we can write integration of ax square plus integration of bx plus integration of c not x bx dx ax square dx and then c dx, right? You can split this integral over entire terms, and then this a is constant, so you can write this outside the integral, and the integral of x square will be x cubed by 3. Then this b is constant, you can write this out, and then integral of x dx is x square by 2. And then c can be taken out, and then the integral of dx, or you can say 1 dx, is just x. And then you write a constant. So this was small c, let's write capital C. Okay, so this will be the integration. Similar to this, I think we can do second part also, right? We have, let's do this one. We'll skip some one question from second. So we have x raised to the power 2 by 3 plus 1 times dx. Same thing here. We can see addition is there, so we can split this integral. We can write x raised to the power 2 by 3 dx plus integral dx, or 1 dx you can write. And then 2 by 3 plus 1 will become 5 by 3. 2 by 3 x raised to the power 5 by 3 over 5 by 3, that will become 3 by 5, and then plus x plus c. All right. So with time you will get it. So if you have something as x raised to the power 2 by 3 and you are integrating this, so you add 2 by 3 plus 1, and then you divide 2 by 3 plus 1. Right? So this was going to be x raised to the 2 plus 3 is 5 by 3, and then divided by 5 by 3. So every time this 5 will remain here and this 3 will come down because you are dividing by 5 by 3. So you will multiply by 3 by 5. So you can just take the reciprocal whenever you're writing to like save one step. Okay, so let's do questions again. So let's skip the first part of questions again. I think we can do that one. Let's do the second part. All right, the second one is integral of 2a over square root of x minus b over x square plus 3c cube root of x square and then dx. So first of all, let's simplify and take this integral over entire term. So when we take this over first term, 2a is constant. Let's take this out. And then you have 1 over square root of x dx. Let's see the second term. This b is constant. Let's take b out. And then you have integral of 1 over x square. Here 3c is constant. Let's take 3c out. So you'll have 3c. And then what is this? Cube root of x square. So this can be written as x 2 by 3, right? So let's take the integral of x raised to the power 2 by 3 dx. So now we can integrate 1 over square root of x. We have learned that this will become 2 root x. Right? This will become 1 over square root of x is 2 square. Right? 1 over square root of x. You write this as minus 1 by 2. Right? And then you add 1 to it. So minus 1 by 2 plus 1 will become x raised to the power 1 by 2. And then you divide by 1 by 2. So 2 will come up. This is 2 root x. So this will become 2 root x. 2 root x times 2a will become 4a root x. Right? And then 1 over x square. Okay. So this is also, we need to write this as x raised to the power minus 2. And then we add 1
So
to it.
can't we think that minus one over root minus one over square will be the derivative of one by
Sorry, your voice is breaking. I didn't understand.
Can you hear me now?
Yeah, yeah.
Also, want the derivative by x by
Derivative of x square.
derivative of one by x.
Okay, your voice is breaking a lot.
One second. So now can you hear me?
Yeah, yeah. Now it's clear.
Yes, I said the derivative of 1 by x will be minus 1 by x squared, right? So we can just substitute 1 by x there.
Yeah, yeah. So you have negative 1 over x square. So negative 1 square integral will be 1 over x, right? We can do that. So we'll get plus p by x, right? Because this
Yes,
negative
sir.
is taken here, right? And using the power rule also, we can see that we have to add 1. So it will become x raised to the power minus 1, which
Minus
is
1,
same
which
as
is,
1 over x. And then
yes,
you have to divide by minus 1, that minus 1, and this minus will become plus. Okay, then see this one. So 2 by 3, we have to add 1. It will become 5 by 3. We have done this over. Yeah, this is x raised to the power 5 by 3, and 3 will be out. Then that 3 and this 3 will become 9. C over 5, and then x raised to the power 5 by 3. 2 by 3 we have done just here, right? This is the. So let's add C to it. Right? If the C's are like same, so you can take any other constant also. You can take K. You can write where K is integration constant. Okay, let's do third one. So we have 2x plus e raised to the power x dx. So this is same as integral of 2x plus integral of ex dx. And this is going to be 2x square by 2 plus ex plus c. This will cancel out. You'll have x square plus ex plus c. Right. Second one also we can just open the bracket and write this as x square minus 1 dx. Right. Then this will become x cubed by 3 minus x plus c. Okay, let's do question number 4. So first part of the question number 4, you just have to open the bracket uh, and just simplify this, right? So you have to integrate x raised to the power 3 by 2, which will be same as we have done this. Then you'll have 2 e raised to the power x. Then you'll have minus 1 over x, which will give you log x. Let's take the second one. Shall we skip the first part? Reconnected. Hello.
yes, I can hear.
Yeah, yeah. So shall we skip the first part, because in first part you just have to uh, split everything, the integral over the every term, and then just integrate.
Yes, I will do that.
Okay, so let's do the second one. We have square root of x minus 1 over square root of x square. All right, so we know that whenever we simplify this, the 2ab term that we'll be having, that can cancel out these two x's. So it's good to open this. So let's expand this. We'll have square root of x square, which will become x,
Yes,
plus second term's square will become 1 over x, and then minus 2 times you have to multiply these two terms, which will like cancel out. So this is
minus
what we'll be having. Now we can just integrate everything. So x dx will become x square by 2, 1 over x will become log x, and
log
then
x
minus 2 dx will become minus 2x.
squared. Yes,
Okay, next fifth one. Let's skip the first part of the fifth one also. It's this, like the same thing. You have to just multiply 1 minus x with square root of x. So also we can do this in one line. 1 minus x times square root of x dx. So let's multiply. We'll get square root of x minus x into square root of x. How much you will be getting? X into square root of x.
then x to the power 1 plus uh 1 by 2, which will be 3 by 2, right?
3 by 2
3 by
dx.
3 by
Right. And when
2.
and we have already integrated this function also before. This will be 2 by 5 x raised to the power 5 by 2, and then this is also we have done already. So let's see
Yes, sir.
the second part. In the second part also we have square root of x multiplied by 3x square plus 2x plus 3 dx. So same thing here, we can open this brackets. So Which terms are we getting? We are getting 3 square root of x and x square. How much will be getting? The degree.
That will be 5/2, I think.
2 plus 1
By
by
2
2
plus
will
2.
be 5 by 2, right?
Yes, 5/2.
Then we have dx. So now we know we can differentiate everything. We can differentiate this, and this also. Sorry, not differentiate. Integrate every of the
Integrate.
inside term.
Yes.
Okay, so here we have multiplied in the next question. What is there? We need to split the LCM
Divide.
over entire term, right? So
Yes,
we
ma'am.
have x cube plus 5x square plus 4x plus 1 over x square dx. So here we can see that two functions are dividing, right? So in differentiation we have this rule for fx over gx, but in integration we do not have any rule, but we can simplify this by taking this x square
Dividing.
over every term. Yeah, you're dividing by x square in the numerator and denominator, you can do that. So x cube over x square will become x, then 5,
X
then
plus 5.
4x over x square will become 4 over x, then 1 over x square, right? Now after this step,
Yes.
we have to just integrate. X will be x square by 2, 5 will be 5x, 4 by x will be 4 log x,
4 log X.
and then plus 1 upon x square will be how much? Minus 1 upon x, right?
Yes, sir, madam.
Okay, so this will be the final answer. Just add c. Okay, same thing we can do in second also, right? Instead of dividing with by x square, we just have to divide by square root of x, right? So let's do this. We have, so first term will be x cube by square root of x. Next will be 3x over square root of x. Then we'll have 4 over square root of x, right?
Yes, it will be
How?
3 minus 1/2.
Yeah,
3 minus 1/2 it will be 5/2.
3 minus 1 by 2, 6 minus 1, 5 by 2, right? And then how
It
is
will
this?
be 5/2 and then 1/2. The 1 minus 1/2, which is 1/2. Plus 4x. Yes.
Okay, so then we can just integrate everything. We have done this quite many times. Okay, let's do seventh question. Here we have x square times this. So first one, how will you do the seventh, the first part of the question 7? So it's quite
Since
similar to what
both
we
of
did in
them
this square.
have,
Yeah.
this is since both of them have the same power as 2,
Hmm.
we can take it as common, right?
Yeah, we can just write this directly as x and
X
2x
into
minus 1 by x and raised to the
whole
whole power.
power 2. Yes.
Right, then
And
this,
then we
then we
can
can write
multiply
this,
x into. Yes.
right? And then we can just, because we do not know anything how to, we do not have any chain rule here, right? In differentiation we have this chain rule that okay, first do this power, then do the inside, but here we do not have something like this. So we need to expand
Yes.
this also. So we can expand this: a minus b whole square, a square plus b square minus 2ab, so 4x square will get. And then we know the integral of everything here, so we can integrate this, right? We'll get like 4x
Yes.
5 by 5 x
Plus x.
4x cubed by 3.
Yes.
Okay, and the second one, x plus square root of x whole raised to the power 3. How can we do this one? So there is an identity for this also, right? A plus b whole raised to the power
Yes, sir.
3. So what is that identity?
So, sir, I
Plus b whole
don't
cube.
remember. But I think it's something.
Okay, you should remember like this these identities until like cubic. So it's a cube plus b cube plus 3ab a plus b. Right? Or sometime you can write this as a cube plus b cube. You can open this to get 3a square b plus 3ab square.
Yes,
All right,
sir.
so we can use this formula now here to write this as x cube plus cube root of no sorry cube of square root. How much that will be? 3 by 2, right? We can write x raised to the power 3 by 2 a cube whenever
Yes, sir.
we do okay, so let's write this square root of x cube, and then we have plus 3a square, so a square means x square, and then b means square root of x, and then 3ab square, so 3a means x and b means square root of x, and then we have to square that. So let's do this. So we have x cube, and then this is x raised to the power 3 by 2, and then this is 2 plus 1 by 2 is 5 by 2, so 3x raised to the power 5 by 2, and then this is 3x square, right? So now we know the differentiation of integration of everything. So this is x4 by 4, then this is 3 by 2, so we know this is going to be 5 by 2 by 5. Right? We will get 5 by 2 in the denominator, but this will be 2 by 5, and then x raised to the power 5 by 2. And then this is going to be 3 is already there, so when you do 5 by 2 plus 1, you will get 7 by 2, and you will get 2 by 7. So 2 times 3 will be 6 by 7, x raised to the power 7 by 2. And then we have the last term, which will be x cubed by 3. That 3 will cancel out, you'll get x cubed.
Yes.
Okay, so let's do the eighth one. X plus a to the whole square dx over square root of x. So here this a is constant. How would you do this? Is by first of all simplifying this square, and then taking the square root of x over the all of the three terms that we are getting, right? So we can write x square plus a square plus 2ax, that is the expansion of the whole square, and then we can take the square root of x over this term, over this term, over this term, and write dx, right? Next we know that this can be simplified to give you x raised to the power 2 minus 1 by 2 will be uh, 4 3 by 2, and then we already know this, so this is 2 raised to the power 3 by 2, so 3 by 2 plus 1 will be 5 by 2, and then you'll get 2 by 5 x raised to the power 5 by 2, and then a square is constant, take that out, 1 over square root of x is 2 root x, and then this is square root of x, so we'll get 3 by 2 and 2 by 3, that is 4 by 3 a x 3 by 2 plus c. Okay, second one, the second part is interesting. Let's do this one. We have here x cube minus x square plus x minus 1 whole divided by x minus 1. So until this point, we were only
Can we
having,
factorize it?
yeah, we can factorize this. Let's suppose, what will you do when you were unable to factorize it? Let's suppose we got something different that isn't factorable. Then what will you do?
I'm not sure.
Then what you can do is just you can divide this, right? Because this is a improper fraction, right? The degree of the numerator is greater than the degree of the
We can
denominator.
use the long division.
Yeah, we can use the long division to write this as some polynomial. You will have this, and then you will have something as uh, a over b, right? So in that case,
Yes,
you can write something as 1 over something, then you can integrate both of the parts, right? But here we can
yes,
see that if we take the square, we'll get x minus 1. If we take the 1, we'll get x minus 1. So that tells us that, okay, we can factorize this and simplify this as
x
x
square plus
square
1.
plus 1, and then x cubed by 3 plus x plus 6.
Yes, yes.
Okay, let's do probably one or two more. Let's see how much we can do. Question 9 first. Okay, so how can we do the first part? This one is like uh, we just have to combine whatever we did in the previous question where e raised to the power
Yes,
something
yes.
log
So
was,
we just take all of the like
right?
we take 6, 5, 4, and 3 to the power, and we cancel all of the e logs and use that.
Right. So after taking that and after removing e and x, what we will be getting?
So we'll get x to the power 6 minus e to the x to the power 5 divided by x to the power 4 minus x to the power 3.
Okay, then how can we now proceed?
Um,
We can probably take something common,
so we
right?
can take it
There are,
out. Yeah, we can
yeah,
take x cube common in the uh, x to the power 5 common above, and we can x minus
yeah,
1 x minus
yeah.
1.
One approach can be if you take x square common, then you'll get x4 minus x3, which will be
Yes, so
completely
we can do
cancelled
that
by.
out.
And if
Yes, yes.
like if it's not the case, then you can take just the highest power. You can take x5 out, so this will become x minus 1, and you can take x3 here, so you can take x5 here, this will become x minus 1. You can take x cube as the highest factor, and then
Then,
this will become x minus 1, so this will also cancel out. 5 minus 3 will give you x square,
then,
same thing you'll get.
yes,
Okay, let's do this one. X raised to the power 6 plus 1 over x plus 1 dx. Now, how can we do this one?
sir, I think so isn't it x squared plus 1? X squared plus 1?
Oh yeah, in denominator you have x square.
Okay, so I think I can take x to the power 6 as x to the power 2 to the power, I mean, into 3. Yeah, and then plus 1. And then we can use the formula that we used in the previous question, the a square, a cube plus b cube.
That was a plus b to the whole cube.
Oh, sorry, but we can use the a cube plus b cube formula here.
Yeah, and what is that formula? A cube plus b cube.
So it will be a plus b in bracket a plus b into a square minus ab plus b.
Okay. So, and what is the formula for a cube minus b cube?
There will be the same a minus b into a square plus ab plus b minus,
Okay,
oh no, plus b, yeah.
plus b
Yes.
square. Yeah. So, if you have like any time, if you have any confusion in which what the term is, so generally you have to remember like the formula is something like this. But if you have any confusion, this is what happened to me, that whenever I had this formula, I had a confusion like whether this minus is there or minus is somewhere here,
Yes, yes,
right?
yes,
I
sir.
had, so what you can do is, when if you want to check if you're correct, you can just expand this again. Like you can multiply a and you can multiply b, and you should get a cube plus b cube.
Yes, sir. And then,
if
yes,
if you're not getting that, maybe some minus error is there, and whichever terms are not canceling out, you can try to put a negative in front of
yes,
them,
sir.
right?
Yes, sir.
And if any case, let's do this second way. If anyway you forgot this formula, right, you do not know this formula, so in general this is division, right? So whenever the degree of the like if you have something as 5 over 2, right, the numerator is greater
Mm.
than denominator, so you need to write this as 2 plus 1 by 2, right? We write this as 2 plus 1 by 2. How? We just divide 2 by
Yes,
5,
sir. It will be 4
we get
plus.
2, and then this can be written as 2 whole 1 by 2, which is same as 2 plus 1 by 2, right? So
Yes,
this is what we will be using here also. So let's try to do this in this way, because there can be some possibility that sometime you don't get uh,
absolutely.
like this formula, right? So let's divide this x
Yes, sir.
square
We'll
plus
use it.
1. We need to divide by x6 plus 1. So we have x6 here, we have x square. We can take how much? We can take x4. Right? x4 times x square. Uh, Base are same. You are multiplying powers will add. You will get x6.
Yes,
And then x4 plus 1 will be x4. So whenever you do not have that term, whenever you do not have that term, you write it somewhere
yes,
else. So then whichever term are writing in this, like the second line, you take negative, you change their sign. So this will cancel out
yes, sir.
positive
That
x,
will
x6
be
negative.
1 minus.
So minus x4, let's write this first because this is the highest degree term, and then write plus 1. All right,
Yes,
now we need x4. We already have x square and we need its negative. So let's write negative x square. Negative x square times x square will be negative x4. And negative x square times positive 1 will be negative x square. Then again, draw the line, change the sign. This negative positive will cancel. This will become also positive x square minus 1. So x square plus 1, sorry, not minus 1, right? Right. So then we have this x square plus 1, x square plus 1, same thing. So let's go with 1. We have x square plus 1. This cancels out. So that tells us, okay, that x raised to the power 6 plus 1, you can write this as x4 minus x square plus 1 quotient into x square plus 1 plus remainder, which was 0. Right. So, like, dividend is equal to divisor into quotient plus remainder, right? That is what we are doing also here, right?
yes, sir. And it's the same as the formula.
Yeah. So then this, let's go to back to our integral. So whatever the numerator was, we can write numerator as this. So let's integrate here. We needed x square plus 1. So we can remove this plus 0 now, and we can integrate. We have x square plus 1. Now you can see x square plus 1, x square plus 1 are same. So you can just cancel them, and we have to just integrate this function right here, right? x4
Yes, sir.
minus x square plus 1. So we can just
It will be
directly,
x to the 5, 5, 5.
yeah, we can just directly integrate them. X5 over 5 minus x cube over 3 plus x. So let's write this also, 5 over 5 minus 3 over
And x
3,
to the power
and
3 by
then
3 plus
plus
x
x
plus
plus c. Same thing we could have done using formula also. I think we'll be having the same
yes,
result,
I
but
think this is like simpler and I won't forget it.
yeah, yeah. So if we don't know the formula, sometimes it's good to have one more, tool to get the answer. And this is the basic thing.
Yes,
Whenever you are seeing something as 5 over 2, we, like, in general, whenever we are talking about smaller grades right now, if we're having our answer in 5 by 2, it's okay to write 5 by 2. But whenever we are in smaller grades, what, every function you need to write this, every fraction you need to write that in proper fraction, right? So if you see anywhere
yes,
an
yes,
improper fraction, this is an improper fraction. So you write that as a proper fraction as 2 whole 1 by 2, right? Or you can write 2
yes,
plus 1 by 2 also. So you get the idea. Okay, so let's continue from right here from tomorrow, and it's like almost over. Also, the last question. Also, let's talk about the last question.
No
Why leave
question.
like one question, right?
Yeah, question.
So f dash x is given, and f0 is given. So this is kind of what we were doing in differential equation, right? So this is somewhere related in differential equation. We were also, you remember, integrating and uh, forming the back the function from the differential equation, right? So if we integrate the differential equation, we'll get our function back, right? And if we differentiate the function, we get that differential equation. So it's the same thing. What
Yes,
is
sir.
given here in the 10th? We have f dash x given as 4x cube minus 6, and f0 is given as 3. We have to determine fx. Okay, so how do we different? So we have learned the first property, that if you differentiate and if you integrate the fx function,
Will will remain the same.
you get fx back, right? So if you have differentiation, what you have to do is just you have to integrate this, and it works like both ways. You
Yes,
can
sir.
do dx first, you can do integration first. It works the both ways. So let's integrate both side. So if we integrate this, integration of f dash x will become fx, right? The differentiation and
Okay.
integration are removed and you get fx. Now let's integrate on the
Perfect.
right hand side. This will be x4 by 4. So 4 will cancel out, and this will be 6x, and then there are constants c. Now this is why this value is given, that to calculate this c value. So we know that at x equal to 0, the function's value is 3. So let's substitute this value back into the function. So we get f0. Let's substitute x equal to 0. We get f0, which is, we know that this is going to be 3, and then x0 is,
And
this will
see,
become, this will become 0, and then you'll only have c. That means c is 3. So what you can do, you can go back to your function and write the function as x4 minus 6x plus 3. Okay, so this was the
yes.
function that they have. Okay, so let's start with the third exercise tomorrow and see if we can. So the exercises in this are, like, I can say, small. Third one is okay. Third one is like quite big. Okay. Okay. So third one is substitution method. So we will talk about this tomorrow. Alright. Thank you for joining
Yes, yes,
today,
sir.
and I'll
Thank
see
you
you
so much,
tomorrow.
sir.
Also, like, do practice a lot, right? Exams are
Yes,
nearby,
sir.
so
Definitely. Definitely.
keep practicing, and whatever questions you have, just whenever we start, you can ask, and we can continue.
Yes, sir. Sure, sure.
Okay. Thank you. Bye.
Thank you so much. Bye, sir.